Keep reminding me, I appreciate it. Okay. So the first question is, it says divide, but it could say equally as well, rationalize the denominator. Or it could say simplify, or find the quotient, which is the same thing as saying divide. Basically, when you see a fraction that has a square root, a radical in its denominator, you want to make sure that you rationalize the denominator. You get rid of that radical from the denominator. And if you recall what we said we would do, we said we would multiply by the conjugate of the denominator. Remember, the conjugate is the identical binomial with the opposite sign. So we're going to multiply this by 3 plus radical 5, because the conjugate of 3 minus radical 5 is 3 plus 5. Of course, whatever we do in the numerator, whatever we do in the denominator, we do the exact same thing to the numerator. And I always like to do the denominator parts first. And I know when I'm multiplying conjugates, I only have to multiply the first and the last, because the outer and the inner for sure will cancel out. So I'll multiply the 3 times the 3, which will give me 9. And the square root of 5, negative square root of 5 times positive square root of 5, which will just be minus 5, because multiplying a square root by itself just gives you the number. So that your denominator turns out to be 9 minus 5, which is 4. Obviously, that is a rational number. There's no radical there, that's fine. What should we do with the numerator? Well, there are 2 things we could do. First of all, we could just put the 6 next to the 3 plus radical 5. In other words, put it in what we call factored form. Just leave it that way. Notice I do see the 6, which is a monomial, and the 4, which is a monomial, could be reduced. I could divide this by 2 and get 3, and this by 2 and get 2. And then I could leave my answer again as 3 times 3 radical 5 all over 2. Or you could, if you wanted to, remove that parentheses. After you've reduced it, after you have divided top and bottom by 2, you could then use the distributive property and go do 3 times 3 is 9. Plus 3 radical 5 all over 2. Both this answer and this answer are perfectly correct answers. Sometimes in a multiple choice test, they will leave the answer with the factors form. Sometimes they'll remove the factor, and remove the parentheses, but don't forget that first you reduce and then you multiply. Let me see. Reggie, that's perfect. Okay, let's look at the next one. The next one is a radical equation. We want to solve the radical equation. I think you're right, Adina. Well, let's see if that is indeed the case. We want to solve this equation, and when we have a radical in the equation, the first thing we want to do is get the radical by itself. So I am going to bring this 4 to the other side so that I get that the square root of 2x minus 3 is equal to 7 minus 4, which is 3. Before I go any further, I look at this number on the other side of the equal sign. It must be a positive number because it must be, because the square root of a number of something is always positive. If this would have been a -3 or a -2 or negative anything, I would have stopped right here and said there's no solution, because it's impossible for a square root to be equal to a negative number. But this is positive, so I can go further. I want to remove the radical sign. I'm going to get rid of this radical, so I'm going to square both sides. When I square this side, I get just the 2x minus 3. Anytime you multiply something with a radical by itself, it removes the radical. We have just plain 2x minus 3. But on the other side, where we have 3, and it's not a radical, we have to actually multiply it by itself. 3 times 3 is 9. And now I have just a regular equation. I bring the 3 to the other, this 3 to the other side. This gives me 2x equals 12. And if I divide both sides by 2, I get that my x equals 6. And I always check the answer because there might be an extraneous root. Notice I'm just going to check it in my head even. 2 times 6 is 12. 12 minus, let's see, we have to go back to the original equation. 2 times 6 is 12. 12 minus 3 is 9. The square root of 9 is 3. 3 plus 4 gives me 7. It definitely works. It is the correct answer. The answer is 6. So that's where we had left off last time when we were doing these radical equations. So I want to do one more radical equation, and then I'm going to go on to the last section in chapter 6. We're now in chapter 6, and on Thursday we will be starting chapter 7, and I'll talk to you. I'll tell you when you will have a test on chapters 5 and 6. This time, as I said, I think this time I'm going to do it on Delta Math, and I will let you know exactly when that test will be. But don't forget, there will be homework on Delta Math for Thursday. There already is some. I think I will be giving you more. Okay, so look at this problem. Suppose I gave you this equation. The square root of x plus 3 plus 3 equals x. Again, I want to do, this is a little bit harder radical equation, an equation that has a square root in it. And we're going to proceed exactly the same way we did before. We're going to get the radical by itself, and then we're going to square, remember, multiply it by itself so that we can get rid of the square root. So the first thing I'm going to do is bring this 3 to the other side. And that gives me the square root of x plus 3 equals, and here, this gives me x minus 3. I can't combine these two because they're not like terms. This is an x. But again, I've got my radical by itself, so I'm going to do what I did before. I'm going to square both sides. Remember, when I square the side, when I multiply the side that has the radical by itself, the square root of x plus 3 times the square root of x plus 3 is just x plus 3. But the other side, I have to actually multiply x minus 3 by itself. I have to do x minus 3 squared. And this is a little bit harder than just multiplying a number by itself because this is a binomial. And I have to square the binomial x minus 3. It doesn't have a radical on top of it, so I actually have to multiply by itself. Now, this side will stay the x plus 3, but this side I'm going to use FOIL. X squared, outer is negative 3x. Inner is negative 3x also. And last is negative 3 times negative 3, which is positive 9. So this really becomes x plus 3 equals x squared minus 6x plus 9. Just to show you, there is actually a way that I could have done the x minus 3 squared a little bit quicker. Again, I could always use FOIL by writing the binomial right next to itself. So they're the identical binomials and you just use FOIL. Or you could see there is a pattern. When you're squaring a binomial, you take your first term and you square it. X times x is x squared. You also square your last term. You do the negative 3 times the negative 3, which is plus 9. But there's another thing you also have to do. You multiply these two numbers together, the x times the negative 3, which is negative 3x, and double it. Negative 3x doubled is negative 6x. Of course, that's exactly what we got over here. It's just a little bit quicker. Notice the reason we double it is because we're doing outer and inner. So I could do it, when I see a binomial square, I sometimes do it this way just to save myself a little time. But let's go back to this. This is a quadratic equation. And the way we solve a quadratic equation is by setting it equal to 0. And I just think it's easier to bring the x and plus 3 to this side, to the right side, because there's less to bring, and also because the x squared term here is positive. So I'm going to minus x from both sides, and I'm going to minus 3 from both sides. And this will be 0, and this will give me x squared. Negative 6x and negative x is negative 7x, and 9 minus 3 is plus 6. And in order to solve this, this is a quadratic equation, I've got to factor it. Okay, so notice how much more work this is, simply because this was not a number but an x. Okay, so here we have, I'm just rewriting it, x squared minus 7x plus 6 equal to 0. It doesn't matter which side you, this is what we more normally, how we look at it, we put the 0 at the end. It means the same thing. And we're going to use our AC method. Our AC here is 1 times 6, which is a positive 6. The B is negative 7. Well, we need two numbers that multiply to positive 6. So obviously, when I add them, they're going to be negative 7 means both of them are going to have to be negative, because a negative times a negative is positive. And it'll be 1 and 6, obviously, because -1 times -6 is +6, and -1 plus -6 is -7. So this is going to give me x squared minus 6x minus 1x plus 6. Remember, we broke up the -7x into -6x and -1x. I don't know why I did it in this order. Here my common factor is x, so I get x minus 6. And here my common factor is just, well, it's just a 1, but it's a -1 because the middle term there is negative. So this becomes x and -6. So here we are. X minus 6 times x minus 1 equals 0. I set each of these equal to 0. X minus 6 equals 0 gives me x equal to 6. And x minus 1 equaling 0 gives me x equal to 1. So it looks like I got 2 answers. A lot of work involved to get 2 answers. But remember, this is a radical equation. Radical equations have to be checked. So let's check our answers. And of course, I go back to the original equation and replace first the x with 6. So that'll give me 6 plus 3 radical plus 3 equals 6. Just I'll leave room to do other check. So the 6 plus 3 is 9. This is the square root of 9, which is 3. And 3 plus the 3 gives me 6. Obviously, that checks. So x equals 6 is a solution. Let's try the x equal 1. So here's a check for x equals 1. We do 1 plus 3 in the radical, plus 3 equals 1. Replacing the x with 1. Well, 1 plus 3 is 4. So this is the square root of 4, which is 2. And this gives me 2 plus 3 equals 1, which is obviously incorrect. In other words, this answer is no good. It is an extraneous root. So the only solution to this equation is x equals 6. If you hadn't done the check, you would have given 2 answers. You're on a multiple choice question. It would have been totally wrong. Even you did all the work correct. So you have to be very careful when it comes to these radical equations to make sure that you are checking your answer. As a matter of fact, I suggest that if you're doing one of these questions on a final exam where it is a multiple choice question, not on Delta Math, because on Delta Math you have to do all the work, but if you're doing it on the final exam, for example, or on any multiple choice test, and it's given to you, you're given choices, instead of doing all the work, just take the answers and check them. Because in the end, you may do all the work and get your right answers, but you're still going to have to check in any case, because you might have an extraneous root. I want to give you one to try on your own. That's going to be a multiple choice. While you are doing that, I'll take attendance, and then we'll go over this question. But I'm going to give it to you as a multiple choice to see if if you could figure out what to do if it was given to you as a multiple choice question. Okay, so here's the example. We have y, square root of y plus 10 plus 2 equaling y. Here's our equation that I want you to solve. Here are the answers. -1 and 6. Two answers. Choice B, just -1. Choice C, just 6. And D, no solution at all. Okay, I'm giving you this, it's a multiple choice, see which choice you think it should be, A, B, C, or D. Okay, I'm erasing this and I'm going to be taking attendance.
Wait, what's D?
D is no solution. Remember, it's that O with a line through it. That means no solution. Okay, Maury. Maury here. Chelsea.
Here.
Hi. I think a few people must have thought because it's election day, there's no class, but there is. Ariana.
Here.
Hi. Adina.
I'm here.
I know you are. I can count on you. Lachey.
I'm here.
Hi. Good.
Hey.
Kava, you were here. I saw you right at the beginning.
Yeah.
Thank you for always being on time or even early. Terrence. Terrence here. Karide.
Here.
Karide here.
I'm here.
Oh, good. Thank you. Were you able to, I reset it for you.
Yeah, I was going to take it today after class.
Okay, you have, as I said, I extended, I just left it open for a few days because I know that I don't check it as often as I should. I hope you won't have any problems anymore. Kezia,
Here.
hi.
Hi.
Faith. Faith Diggs. Ethan.
Here.
Hi. Isabella. Serenity.
Here.
Hi.
Hi.
Reggie, I know you've been answering questions, so you must be here. Zamia. Zamia, Brandon, Seraphine,
I'm here.
hi. Marissa, Renee,
Here.
hi.
Hello.
Sky,
I'm here.
good. Good afternoon.
Good
Jaden,
afternoon.
Jaden Roberts. Kennedy, Felicia,
I'm here.
Natalia, Michael, Cassidy, Megan, Kalia, Lauren.
Here.
Yeah, I count on you. Thank you. And Kayla Zachary. All right, I think we're set. Let's try this problem. I see a couple of people have picked C as the answer. Let's see. Since this is a radical equation in which I'm going to have to, once I've solved it, I'd have to check the answer anyhow. Why don't we just take the answers that they gave us and try them out? Maybe we'll be lucky and we'll see which ones work. Obviously, there are really only two things that you have to check out. It's the number -1, it's the number 6, because this is telling us that both of those numbers work. This is telling us only the -1 works. This is telling us only the 6 works. And this is telling us, this is the symbol that tells us there's no solution. In other words, nothing works. So the only possibilities they're giving us are -1 and 6. So let's check. So first I'm checking with -1. So I'm going to replace the y with -1. So that'll give me the square root of -1 plus 10 plus 2 equaling -1. Now the -1 plus 10 is 9, and the square root of 9 is 3. So we're getting 3 plus 2 equaling -1, which obviously doesn't make sense because 5 does not equal -1. This answer does not work. which means that this is obviously wrong, because if -1 doesn't work, then both of them certainly can't work. -1 doesn't work, and this answer. So what we have to now check is, let's see if the y equals 6 works. If it doesn't work, that will mean that we'd have to pick choice D. If it does work, we'll pick choice C. So here we are, replacing y with 6. So we get 6 plus 10 radical plus 2 equaling 6. Now 6 plus 10 is 16. And the square root of 16 is 4. So we have 4 plus 2 equals 6. And that, of course, is true. So my correct answer, those of you who picked C, are absolutely correct. And notice it was a much easier problem to do because it was multiple choice. I only had to do the check. I didn't have to go through the whole process of solving it. Of course, we could have solved it. I assume if when we solved it, the answers that would have come up in the solution are 1, -1, and 6. I still would have had to do the check. So here's a way to save yourself a time in case it's a multiple choice question. In some cases, multiple choice questions make it easier. In other cases, it makes it harder because the choices look so similar that if you're not careful, you might pick the wrong choice just by not looking carefully enough. So there are certain questions where multiple choice makes life easier. Some places it doesn't, but this is a case where if you have it as a multiple choice, it does save you time. Okay, so that takes care of radical equations. So what we're going to do in the rest of this chapter is talk about a number system that comes up occasionally. It's not the regular number system that we use on a general basis, but it is a number system that has definite applicability in certain real life situations. Electrical engineers use this number system, etc. The number system that I'm talking about is called the complex number system. And I'm going to describe what this new number system is, as opposed to the number system that we've been using until now. The number system we've been using until now is something called the real number system. And when we talk about the numbers that are on the number line, all those numbers that fit on the number line are the real numbers. So they're any type of fraction or decimal. It could be an ending decimal. It could be a non-ending, non-repeating decimal. Could be like the square root of 2. If you wanted to go to find out what the square root of 2 is, it would turn out to be a non-ending, non-repeating decimal, but it is a decimal and it is a real number. So what type of numbers are not real? The only type of numbers that we have sort of mentioned so far that do not belong to the real number system are numbers like the square root of -25. A square root of a negative number. We don't have any real answer for that. We can't say it's 5 because 5 times 5 won't give us -5, it'll give us +5. And we can't say it's -5 either because -5 times -5 is also +25. There's no way you can get a real number to multiply by itself to be negative. because real numbers are either positive or negative, and anytime you multiply either a positive or a negative number by itself, the answer turns out to be positive. So what do we do with this type of number? As I said, in the real number system, we just say, too bad, can't do. But in this new set of number, which is an extension of the real numbers, which includes one additional number, we can talk about dealing with these square roots of negative numbers. What's our new number? That new number is the square root of -1. And we've got to give it a name and a symbol. And it can't be something that we've already used because this is something new. I can't call it 17, like 17 isn't a real number 17. We give it a name, I. Now, if you notice how I write the I write the I not just with a line and a dot, because especially on Zoom, you probably will see the line and you might not see that dot. Sometimes I make the dot big enough and you will think it's a 1 and it's not a 1, it's an I. So I will always write the I, either like this italicized I, or even like a script I don't care which you would. Don't just use a line with a dot. It's too, should I say, dangerous to do. It's too likely that you will make a mistake and confuse it with a 1. It is not a 1, it's the square root of -1, and the symbol that's used for it is I. Now, this is the one I will generally use. I think it's very obvious that it looks like a script I. So how does that take care of a situation like the square root of -25? Well, if we have something like the square root of -25, remember how we simplified radicals? We broke them up into 2 parts. We can break this up into the square root of 25 times the square root of -1. And the square root of 25, now that we know, that's a real number. That's the real number 5. And the square root of -1 is our new number I. So the square root of -25 is 5I. We sometimes call these numbers imaginary numbers. That's where the I comes from the word imaginary. And the only reason they're called imaginary numbers because we called the original set of numbers we were dealing with before real. So these are numbers that are not real. Well, something that's not real, we can call imaginary. And that's where the name came from. It doesn't mean it's a figment of imagination. These are actual numbers that are used in certain very special circumstances. On a normal basis, we don't use those numbers, but they are numbers that can be used. And you will know that you can use those numbers because there are a number of ways you'd be told about them. You could say, give your answer as an imaginary number, then you know to use I. You might say, give your answer as a complex number. Complex are also another word for imaginary. Or it might say, give your answers in what we call A plus BI form. Anytime you see something of that nature, it means that you're allowed to have an I in your answer. You're allowed to do the square root of a negative number and use this special number I. Otherwise, if it says give your answer as a real number, then you can't have the square root of a negative number. You can't have an I. So we're going to explore how to work with these numbers that have I's in them. I think it's pretty easy to change a number to its I format. How do we, and then we're going to talk about how to add, subtract, multiply, and divide these numbers. So first of all, if I give you something like the square root of negative 50, and I say I want you to simplify it and write it in terms of I, what I would do in that case is I would break it up into, well, the negative will be -1. That's one piece of it. And the 50 part, I'll break up into 25, which is a perfect square, and 2. Like we did before, whenever we had 50, we broke it up into 50, 25, and 2. So this will give us, the square root of 25 will give us 5. The square root of 2 will stay the square root of 2 because it's irrational, it doesn't have a square root. And the square root of -1, we will always write as I. In other words, we won't leave it as a negative number inside a square root. We will write it in terms of I. Sometimes, instead of putting the I at the end, we write it 5I square root of 2. And that's just a convenience because you don't want to, when you're making a square root sign, sometimes you're writing very fast and the line gets too long and it'll look like the I is inside the radical. It's not, it's outside the radical. So I put all the numbers outside the radical to the front. So that's 5I and square root of 2. Of course, if you have something like the square root of -100, that you could just break up into 100 and -1, because the 100 is a perfect square, and you get 10I. So there's nothing more complicated about simplifying radicals that have negatives in them. Just put a -1 at the end, and when you take it out of the radical, it becomes I. Remember, I stands for the square root of -1. It is in other words, I is not a rational number. It's a radical. And we have to keep in mind, especially if we'll see it in a denominator, that it's a radical in a denominator and we have to deal with it. But we just write it in a simpler form as the number I. Now, adding, subtracting, and multiplying with I's is relatively simple. It's, you follow just the regular rules of working with algebra. In other words, if I were to ask you to simplify this, suppose I gave you an expression like this: 2I minus 3 times -6I plus 8 minus 23. I gave you an expression that had regular numbers and imaginary numbers, I's. And I asked you to simplify it. Well, you're going to treat this like regular algebra. In other words, you're going to remove the parentheses by using the distributive law. We're going to get 2I. Now, -3 times -6I will give me positive 18I. -3 times positive 8 is -24. And just bring down the minus 23. So we remove the parentheses. And now we're going to collect the like terms. And we want to put our answer in what we call A plus BI form, which means put the numbers that don't have I first. That's negative 24 and then negative 23, which gives us negative 47. And the I numbers, the 2i and the 18i is just 20i. It's regular algebra. So my answer comes out to be negative 47 plus 20i. This is a complex number because it's a combination of a real part, the negative 47, and the I part, the 20i. Notice that's why it's called A plus BI form. Adding, subtracting would be the same. You just do regular subtraction like you do in regular algebra, and it will give you the right answer. Again, if you have a square root with a negative number in it, you first have to convert it to I. In other words, if you have the square root of negative 36, first write it as 6i and then work with it. Don't work with it as a square root of a negative number. You work with it as if it in terms of i's, and you use regular algebra. Okay, so let's say I gave you, we talked about adding and subtracting. Let's talk about multiplying for a second. Before I do anything complicated, let's first talk about what happens when I have, well, I know what it is. What happens when I have I squared? Remember, I squared is I times I, so it's a square root of negative 1 times a square root of negative 1. And we know when we multiply a radical by itself, like the square root of 5 times the square root of 5 just gives us 5, the square root of negative 1 times the square root of negative 1 will give us negative 1. This is the most important thing you have to remember about working with i's. Working with i's is like working with like any numbers in algebra. The only thing that you have to be careful about is when you have an I squared. I squared is a real number. It's the regular number negative 1. It's not imaginary, it's I. It isn't an I, it's just a regular negative 1. And anytime you come across an I squared, then you want to replace the I squared by negative 1. Notice, you don't, I is the square root of negative 1. You leave it because it's a radical. It's an irrational number. But I squared doesn't have any square root in it. It's just regular negative 1. And therefore, instead of writing I squared, we're going to write negative 1. So if I gave you something like this to multiply, 6 minus 7i times 5 plus 3i. I told you I want you to multiply these two complex numbers. How do I know they're complex numbers? Because they're numbers that have i's in them. They're not regular real numbers. They're an A plus BI form. This would, your A would be 6 and your B would be negative 7. This is really 6 plus negative 7i. And this is 5 plus 3i. They are numbers in the form of A plus BI. And we're going to multiply them. They are binomials, so we're going to use FOIL. First, 6 times 5 will be 30. Oh, outer, 6 times 3i is 18i. FOI, inner, negative 7i times 5 is negative 35i. And L is last, negative 7i times positive 3i, which gives me negative 21i squared. Don't forget, I times I gives you I squared. And remember what I said about I squared. Whenever you come across an I squared, you're going to replace it with negative 1, because that's what I squared equals. So this will give you negative 21 times negative 1, which is a positive 21. No I in this term. And I now combine the like terms, the 30 and the 21, which is 51. And the 18i minus the 35i, which is negative 17i. And this is your answer. Notice it's an A plus BI form because it has a real number and it has an I number. That's how we multiply complex numbers. Notice you don't really have to know too much more than you already know. If you know that I squared equals negative 1, you really can work with these imaginary and complex numbers. Let me give you two to try. I want you to try these two problems. Okay. Problem number 1. Do 2 minus 3i squared. And problem number 2 that I want you to do is 4 plus 7i times 4 minus 7i. Okay, I'm going to erase this part now. Give you a few minutes to try these two problems. Okay. I see that some people already have answers. Let's do the first one. And I'm going to do it two ways. I'm going to do it by using FOIL, and then I'm going to do it the way I said you could do squaring a binomial. Let's first do it by FOIL. We have to write 2 minus 3i times 2 minus 3i. Don't forget, anytime you have a binomial and you're multiplying it by itself. If you're using FOIL, you have to write it twice. And we do. First, 2 times 2 is 4. Outer is negative 6i. Inner is also negative 3i times 2, another negative 6i. And last is negative 3i times negative 3i, which is positive 9i squared. Don't forget, I times I is I squared, which equals your negative 1, because it's an I squared. So this becomes 9 times negative 1, which is negative 9. Remember, it's 9i squared. You're multiplying the 9 times the I squared. So now you have to combine the 4 and the negative 9, which is negative 5. And this negative 6i and the negative 6i together is negative 12i. And your answer came out to be negative 5 minus 12i. And remember, you put the negative 5 first because that's the real part, and the negative 12i second. This is a plus bi form. That's how you write your complex numbers. You could have, just as a recall, you don't have to do both of these. If you wrote it as 2 minus 3i squared, you could remember what I said about squaring a binomial. You square the first term, 2 times 2, and you get 4. You square the last term, negative 3i times negative 3i is positive 9i squared. And then remember, you multiply these two together, 2 times negative 3i is negative 6i, and you double it, that's your negative 12i. And again, this is your negative 1, and now it finishes the same way. This is 9 times negative 1 is negative 9, so you have 4 minus 9, which is negative 5, and you minus 12i. It's a little bit faster. Whichever way you prefer doing it, you get the exact answer. The answer for that first one was negative 5 minus 12i. Okay, so now I see we have a few people have answers to the second question. Notice this is not a binomial squared because one is 4 plus 7i and the other one is 4 minus 7i. So you want to multiply these two together. So when you multiply these two together, if you remember, they're conjugates because they're the identical binomials except one has a plus and one has a minus. So you don't have to do the whole FOIL. You just have to do the first and the last. Remember, that's the beauty of multiplying conjugate binomials. 4 times 4 gives you 60. You know, outer and inner are going to cancel out. Last is 7i times negative 7i, which is negative 49i squared. And again, my I squared is negative 1. So this becomes 16 plus 49. And 16 plus 49 is just the real number, 65. It turns out, even though the two numbers we were multiplying are complex numbers, numbers of the form a plus bi, their answer is a regular real number. You don't get any i's in your answer because the outer and the inner is canceled out. So your final answer is just the number 65. Okay, so now we know how to add, subtract, and multiply numbers with i's, complex numbers. I want to just do one more thing, and that's do division. How do we divide numbers that have i's in them? And there are two types. You might have something that looks like this. Let's say you had 2 over 5i. What do you do when you have an I in your denominator, because that's really, even if it says divide, or it says simplify, or it says rationalize the denominator, it's similar to having a situation where you have a square root in your denominator, because I is actually a radical. It really means the square root of -1. It's a symbol, but it is a square root. So when we say simplify or divide, we want to make sure that we don't have any I left in our denominator. So if your denominator is a single term like 5I, then what you do is you just multiply the top and bottom of your fraction by I. You don't have to multiply. The 5 is not a problem. It's the I that's a problem. So just multiply by I on top and on bottom. Of course, you're just multiplying by 1. So your numerator becomes 2I, and your denominator becomes 5I times I, which is 5I squared. And again, now that we have this I squared, we can replace it with -1. So this becomes 2I over -5, because 5 times -1 is -5. Now, usually we don't leave a negative in the denominator. We generally put it in front and just write it as -2I over 5. But having an I in the denominator, when you have only a single term, there's nothing in between the 5 and the I, it's a single term, you just multiply top and bottom by I. So what happens if you have a binomial in your denominator? Well, let's say I had something like this. Let's say I had two plus 3I over 2 minus. What if we had an expression? Well, basically what we wanted to do, and I might say divide 2 plus 3I by 2 minus I, or it might say rationalize the denominator, or it might say simplify. All these mean the same thing in this case. The big problem here is that I that's in the denominator. Just like we don't want a radical in the denominator, we want a square root in the denominator, we don't want an I in the denominator. And we're going to do exactly what we did when we had square roots in the denominator. We're going to multiply by the conjugate of the denominator. Now, what's the conjugate of 2 minus I? It's 2 plus I. Same binomial, opposite sign. We're going to have to multiply by 2 plus I in the numerator and in the denominator. Okay, and as you say, I always like to do that denominator part first, because you only, when it's conjugates, you only have to do first and last. So you do first 2 times 2, which is 4. And last negative I times positive I, which is minus I squared. And my I squared is my -1. So now I have 4 minus -1, which is 4 plus 1, or 5. My denominator comes out to be the real rational number 5. No I's in it, no square roots in it, fine. What about the numerator? Well, the numerator, I have to actually do the FOIL. They're not conjugates, they're not squaring something, you have to do FOIL. So first, 2 times 2 is 4. Outer, 2 times I is 2. Inner, 3i times 2, which is 6i. And last, 3i times I, which is 3i squared. Just regular FOIL, don't forget, 3i times I is 3i squared, and that I squared is now going to be replaced by -1. So this is going to be 3 times -1, which is -3. Now let's combine the like terms. I have a 4 and a -3. Those don't have any i's, that's 1. I have a 2i and a 6i, that's an 8i. So my answer comes out to be 1 plus 8i over 5. Now, if they ask you to put it in a plus bi 4, and very often they do, that means they don't want it all over a single denominator. They want each number separate. Well, this means 1 over 5 plus 8i over 5. That's the 8 plus bi form that they want. But that's the answer they want. Notice it is a complex number, but it doesn't have any i's in the denominator. It has an I in the answer, but it's not in the denominator. So that's how we deal with simplifying fractions that have i's in their denominators. Okay, I'm going to give you one to try, and then I can think we're finished with the class. I'm going to give you one now. Here's one for you to do. Okay, it's 4 in the numerator and -4 minus I in the denominator. 4 over -4 minus I. Let's see if you can simplify this fraction.
Wait, do we have to like show it as a fraction at the end?
Yes, I want you to write it in a plus what we call a plus bi form. Okay, I think we can try this together now. Again, basic problem. Then I in the denominator. We don't want a square root in the denominator. We don't want an I in the denominator. So we have to multiply by the conjugate because this is two terms. This is -4 minus I. So what is the conjugate of -4 minus I? Remember, when you're taking the conjugate of a binomial, the only thing you're changing is the sign between the two numbers or letters or whatever they are. So this is going to be -4 plus I. Don't forget, it's not 4 plus I, it's -4 plus I, because you only change the number in the middle. So that's what we're going to multiply both the top and the bottom by. Well, let's start with our denominators. Again, these are conjugates, so we just have to do first and last. -4 times -4 is +16. Last, -I times +I is -I squared. Again, my I squared is a -1, so this is negative a -1, becomes 16 plus 1, or 17. The denominator becomes the plain real number 17. Okay, what about the numerator? Well, either we could leave it in the what we call the factored form, like this, but usually we remove the parentheses and we get -16, 4 times -4, plus 4I over 17. If it doesn't say A plus BI form, it just asks you what's the answer, you could leave it like that. But if it asks for A plus BI form, that you want to separate it into -16 over 17 plus 4I over 17 is the.
Yeah, that was kind of what I was kind of like asking you, like, cause like I haven't done this type of problems like ever, so like they're kind of new to me. But it's I just wanted to make sure like if you can put it as like the
This is correct. This original answer is correct.
nah, cause I was using the bottom one,
But
so
this is
I didn't know
the
if
better answer. This is really the better answer.
okay.
Okay. Again, it's hard to say on a multiple choice test. They could give you either of the choices and they both be correct. But if it says specifically A plus BI form, then this is the answer that they want.
All
And
right.
really the better format. Okay, Reggie, good for asking that. Okay, I think we're okay now. And I see a few people have the answer. That's great. So I think we can end class now. It's a little bit early. Look out for homework on Delta Math. There is some already listed, but I probably may give you an additional problems. And on Thursday, this is really the end of chapter 6. So we have finished 2 chapters now. So I do want to talk about a test, and I'll look at the schedule and I'll figure out, again, if it's on Delta Math, which I plan to give it, I'll probably give you a week's time to do it in. Also, if anybody's here and has not taken either the midterm or that test 1 on Blackboard, if you haven't done either of them, it's opened up and you can take it now. Make sure you take it because you will not, otherwise your averaged into your mark is a 0 for both of those tests if you haven't taken it, as well as test on Delta Math. It is open. You can take the test on Delta Math. It's available probably until the end of the term, but you must do those tests in order to get credit, because otherwise it is averaged in as a 0. Okay, have a good day. And we will see you on Thursday.
Have a good day, Professor.
Have a good day.
Bye-bye.